Tonight, Earth's skies offer a rare spectacle as our familiar moon shares the stage with temporary companions. These mini-moons, caught in Earth's gravitational pull, create a mesmerizing celestial dance that happens only once every few decades. Let's explore one of astronomy's most fascinating secrets, Earth's second moon. While it's not a permanent fixture like our familiar lunar friend, this natural satellite, named 2020 CD3, was spotted orbiting Earth in 2020. About the size of a small car, this cosmic wanderer got caught in Earth's gravity field and stayed with us for about 2.7 years. Scientists call these objects temporarily captured orbiters, or TCOs, but we like to call them mini-moons. Think of them as cosmic visitors that drop by for a brief stay before continuing their journey through space. These mini-moons usually measure between 1–2 meters across and can circle Earth in unusual looping patterns before breaking free from our planet's gravitational embrace. What makes tonight truly remarkable is the unique alignment of multiple mini-moons with our regular moon. These temporary satellites are lining up in a way we haven't seen in over 30 years. From Earth, they appear as tiny moving dots of light, much fainter than our moon but still visible with good binoculars. This alignment happens because the mini-moon's orbits occasionally sync up, creating a cosmic dance that astronomers can predict using complex calculations. While our regular moon appears as a bright disk in the sky, these mini-moons look like moving stars, taking different paths across our night sky. This rare show gives us a chance to spot up to 3 mini-moons at once, something that won't happen again until the 2050s. Let's break down how these mini-moons actually dance around Earth. Imagine Earth as a giant magnet, pulling on everything nearby with its gravity. This gravitational pull creates what scientists call a gravity well. Think of it like a huge invisible bowl in space. When space rocks pass close to Earth, they can get caught in this bowl, spinning around like marbles. But here's the cool part. They don't just go in simple circles. The combined pull from Earth, our regular moon, and even the sun makes these mini-moons follow twisted, looping paths. Sometimes they spiral closer to Earth, other times they swing far out, but always following patterns we can track with modern telescopes and computers. This complex movement is why astronomers can predict when and where we'll see these cosmic visitors in our night sky. Earth's gravity doesn't just affect our main moon, it creates a cosmic dance floor for smaller objects too. These mini-moons are usually asteroids or space rocks that wander too close to Earth's gravitational pull. Unlike our permanent moon, they stay for a short time, typically a few months to a few years. Some follow weird figure-8 patterns around Earth, while others loop around in more circular paths. The most famous mini-moon we've spotted was 2020 CD3, which hung around for almost 3 years before saying goodbye. These space rocks range from the size of a washing machine to a small car, and while they're too small to see with the naked eye, powerful telescopes can track their movement. Most mini-moons complete their Earth dance about once every 2 to 3 months before breaking free and continuing their space journey. Want to catch this rare celestial show? The best time to spot these mini-moons is between 2 a.m. and 4 a.m. when the sky is darkest. You'll need a good pair of binoculars or a small telescope, and it's crucial to get away from city lights. Look for the regular moon first. It's your main reference point. The mini-moons will appear as small moving dots nearby, following slightly different paths across the sky. The best viewing spots are high locations with clear horizons like hilltops or open fields. A star tracking app can help you locate these cosmic dancers, as they'll be marked as special events tonight. Remember to give your eyes about 20 minutes to adjust to the darkness and bring a comfortable chair. Sky watching requires patience. Long before modern astronomy, many cultures around the world had stories about multiple moons. The ancient Greeks believed Earth once had 3 moons, while some Native American tribes spoke of a time when 2 moons raced across the sky. In China, old texts mention the ghost moon, a mysterious shadow that sometimes appeared alongside the regular moon. The Mayans were especially good at tracking objects in the night sky and left detailed records of what might have been temporary moons. These stories weren't just myths. They might have been early observations of the mini-moons we study today. The Vikings even had a special name for unusual moving lights in the sky that followed the moon, calling them moon's children. Ready to photograph this amazing sky show? Let's cover some essential tips to capture these elusive mini-moons. You'll need a camera that can handle long exposures. Any DSLR or mirrorless camera will do great. Mount it on a sturdy tripod and use a remote shutter or timer to avoid camera shake. Set your ISO between 1600 and 3200 and use a wide aperture lens. f2.8 or wider is ideal. Try exposure times between 15 to 30 seconds. This helps catch the faint light from the mini-moons. Here's a pro tip. Take multiple shots of the same area and stack them later in software to bring out more detail. Just remember to turn off your autofocus and manually focus on the stars. While our main moon strongly affects Earth's tides and climate, these mini-moons have such tiny effects we can barely measure them. Our regular moon pulls on Earth's oceans, creating the tides we see at beaches, but mini-moons are too small to cause noticeable changes. They're more like space pebbles compared to our moon's boulder-sized influence. Even when several mini-moons visit at once, their combined gravitational pull is weaker than that of a passing cargo ship on the ocean. However, studying these temporary visitors helps scientists better understand how objects move in space and how Earth's gravity affects nearby asteroids. This knowledge is valuable for protecting Earth from potential space rocks that might come too close for comfort. With all these objects floating around Earth, how do scientists tell the difference between mini-moons and space junk? It comes down to a few key factors. Natural mini-moons typically follow smooth, predictable paths shaped by gravity, while human-made debris moves more erratically. Scientists also study the way these objects reflect light. Space junk often has flat metallic surfaces that create distinctive flashes, while natural rocks tumble and reflect light more randomly. Using powerful telescopes and radar, researchers can even determine what these objects are made of. Space debris usually contains materials like aluminum and titanium, while mini-moons are made of rock and minerals typical of asteroids. Looking ahead, astronomers have mapped out when we can expect the next big mini-moon gatherings. The next major alignment, similar to tonight's show, is predicted for 2052, when Earth's gravity is expected to capture at least 2 asteroids at once. But don't worry, we'll see smaller mini-moon visits before then. Scientists use powerful computer models to track thousands of nearby asteroids, and they estimate we capture a new mini-moon every decade or so. Some exciting predictions suggest a car-sized asteroid might become a mini-moon in 2028, potentially staying with us for up to 5 years. These forecasts help astronomers prepare their telescopes and give space enthusiasts like us something amazing to look forward to. Thanks for joining us on this cosmic journey through Earth's temporary moons. The night sky never fails to amaze us with its wonders. If you enjoyed learning about our celestial neighbors, hit like, subscribe, and share this video with fellow space enthusiasts.